Right, welcome everyone. This is the TLS Virtual Hosting with a Apache Tomcat. Our agenda for today, I'm going to start with a quick introduction and then go on to discuss what virtual hosting is and then what additional complications arise when that gets added into TLS. Then I'll look at using TLS Virtual Hosting currently with 6, 7, and 8, and then the new features that are available if you use Tomcat 9. I'll wrap up by talking about our future plans, particularly for Tomcat 8, and then I'll run through any questions at the end. If you do have any questions or you think of any questions as we're going along, please do type them into the chat window. Make sure you send them at least to me, Mark Thomas, so I can read them at the end, and then I'll just go through at the end and cover the questions we have. Okay then, right. So, quick introduction. As I said, my name's Mark Thomas. I've been an Apache Tomcat committer since December 2003. You'll find me in various places around the ASF, posting under markt@apache.org, but primarily working on Apache Tomcat. I'm the release manager for Tomcat 8 and 9, and I'm also on the expert group for a number of the Java EE specifications that Tomcat implements. My day job is actually as a consultant software engineer at Pivotal, where really I have a very simple instruction for my line manager: go and do good stuff on Tomcat, and I get to spend about 90–95% of my time doing that. The current focus, as those of you that have been following the dev mailing list will know, is working on development of Apache Tomcat 9. So, what is virtual hosting? Very simply, it's serving multiple websites from a single web server. So if we use the Apache Software Foundation as an example, the ASF has a single server that serves all of the top-level project sites. That's tomcat.apache.org, httpd.apache.org, as well as the main Apache site, www.apache.org, and it also handles a number of aliases for those sites as well. So all of that is under a single server. So with that, when a server receives a request, how does it actually know which one of the potentially hundreds of sites it's hosting the request is for? Well, if we look at a simple HTTP request, here we can see we've got an GET request. It's for the index page, and it's over HTTP 1.1. But the important bit is the next line, which is the host header, and that tells us the name of the virtual host. Now, not in a typical request, then there'd probably be 3 or 4 additional headers as well. Oops, wrong screen. Now, if we translate that into Apache Tomcat configuration, if you have a look in server.xml, then it's the host element that's nested within inside the engine that represents the virtual host. And each host has a name and 0 or more aliases. Now, those names and aliases don't permit wildcards, and they don't permit regular expressions. They must match exactly. We do have an open Bugzilla enhancement request, 18500, for allowing regular expressions. That's actually the longest open Tomcat enhancement request we have, and the reason it's been open for so long is primarily because implementing it is going to have a performance impact that nobody's particularly happy with. Parsing the host header and processing the host and identifying which host to use is something that has to be done for every single request. So it's on the critical path for the request. And adding regular expression matching will be significantly slower than the matching we do at the minute. And to date, nobody has really stepped up and said, right, okay, we need to find a way to solve this. I think it is something we are going to need to solve in Tomcat 9. And what I suspect is going to happen is some form of trade-off between a small reduction in performance, but probably not quite full regular expression matching. So some sort of halfway house is going to have to be found. So as I said, at the moment, the name has to be an exact match. So the name of the virtual host or one of its aliases is matched to the HTTP host header. If there's no match, then the default virtual host is used. And in Tomcat, the default name for the default virtual host is localhost. That's why when you start up a standard Tomcat installation, if you look inside the conf directory, you have one directory called Catalina. That's the default name for the engine, and then underneath that you have localhost, and that's the default name for the localhost. Then as applications get deployed that have context.xml files, if they're deployed to that virtual host, then they'll end up in the localhost directory. So if we take a look at a little snippet from server.xml, here we can see we've got our engine. That's got its default name of Catalina, but here we've specified a default host of www.apache.org, and then within our engine we've nested two, potentially many more virtual hosts. And you'll notice that each host has been given its own app base. Life is awfully complicated and usually quite painful and messy and bug-ridden if those app bases overlap. It is strongly recommended that when you have multiple virtual hosts, you give each virtual host its own separate independent app base. Life is so much simpler if you do it that way. If you want to know a little bit more about how to set that up and want a more detailed step-by-step guide, then in the Tomcat documentation, the virtual hosting how-to, that will take you through that step-by-step from purely a HTTP perspective. It doesn't look at any of the HTTPS stuff, which is what we're going to look at today. So how do things get a little bit more complicated when we add TLS to the mix? Well, TLS sets up the secure channel before any HTTP communication takes place. And that's a good thing, because the whole point of using TLS is that we want to protect all of the communication, so it has to set up that secure channel before we start sending HTTP. Well, that seems reasonable. Well, if we work our way through this, TLS uses certificates in order to authenticate the servers, and those certificates include the host name. So the server has to send the right certificate to the host the user wants out to the user as part of establishing that secure channel. But the problem is that the server doesn't know which host, and hence which certificate, until it receives the HTTP host header from the client. But the client's not going to send that until the channel's been established, and establishing the channel means sending the certificate. So you have this chicken and egg problem whereby the server can't send the certificate until it knows which host the client wants, and the client isn't going to tell the server which host it wants until the server sent the certificate. Now, there are a couple of different ways around this particular problem. If you're looking at Tomcat 6, 7, and 8, then you can work around it with some limitations, and those limitations really boil down to one connector, one TLS host name, or TLS virtual host, one certificate. So you have to use the same TLS certificate for every virtual host. And this really goes back to a limitation with Java Secure Sockets Extension, JSSE, which is Java's TLS implementation. So how can it work that we can have one certificate serving multiple virtual hosts? Well, one way is with wildcard certificates. So, for example, the ASF has a star.apache.org certificate, and that will work for www.apache.org, tomcat.apache.org, httpd.apache.org, and so on. Unfortunately, it doesn't work for plain apache.org if we drop the www. And it doesn't work for some of the aliases like www.openoffice.org, which is an alias for openoffice.apache.org. The way you can handle that is with something called subject alternative names, and that essentially lets you put into a certificate multiple independent names. Don't have to be related to each other in any way, as long as they're valid domain names and you own them. You can put those multiple names into a single certificate. Generally, the more names you want to put into the certificate, the more it costs you. So with a combination of either a wildcard certificate or subject alternative names, most simple virtual hosting scenarios can be solved with a little bit of creative thinking. It's the complicated ones that tend to cause the problems. So back to that chicken and egg problem. The real solution, rather than using the wildcard or the subject alternative names workaround, is to use something called server name indication, SNI. And this is a TLS extension that breaks the chicken and egg problem by passing the requested host name in the TLS handshake. That way, the server is able to identify which is the right certificate, present it to the client validates the host name, and then everybody is happy. The good news is that SNI support was added to GSSE in Java 8. The bad news is that that support is pretty much useless. And the reason for that is that the whole GSSE API remains limited to having one certificate per listening socket. And the SNI support that was added really is only providing hostname filtering. So what that lets you do is during the TLS handshake, when the SNI extension is received, you can read the hostname that the client asked for, and all you can do is say, well, do I accept that or don't I? You have no ability at that point to say, well, yes, I do accept that, and this is the certificate you can use. The key "and this is the certificate you can use" bit is missing, which is what makes the SNI support largely useless. So to do virtual hosting, you have to do it rather more by hand. You have to maintain multiple SSL contexts. SSL context is a GSSE object that effectively represents the server certificate and associated configuration. The hard part is you have to manually parse the TLS handshakes. You have to buffer the incoming network data. You have to look ahead within that data, find the SNI extension, parse it, extract the host name, then link up that particular connection with the right SSL context, create the associated SSL socket, and then send the data on its way to do all its normal processing. And the slightly surprising thing is, believe it or not, that is how Oracle recommends that you do virtual hosting on the server side. With Tomcat 9, that is what we've implemented. So you have full SNI support with the NIO connector, the NIO2 connector, and APR native. And we've actually gone a little bit further. Not only can you have one connector with multiple TLS hosts, each TLS host can have multiple certificates. The reason that's useful is that the ciphers that are available to a client depend on the certificate type. So if you have multiple certificate types available, the client has a larger range of ciphers from which to choose from. Now, obviously, going from one connector, one TLS host, one certificate, to one connector, multiple hosts, multiple certificates, then we've had to change the TLS configuration a bit just to handle that. So what does it look like? Well, this is an extract from server.xml with Tomcat 9 when we've got a couple of TLS virtual hosts configured on our connector. So I've left out most of the connector options and just focused on the TLS bits. So we've got our SSL host config element nested within the connector. In fact, here we've got two of them, and each of those represents a single virtual host. You'll see the first one is for www.apache.org, the second one is for tomcat.apache.org. And then within that SSL host config, we've nested our certificates. You'll see that Apache.org has got one certificate, whereas Tomcat has got two certificates, one RSA, one EC. EC is elliptic curve. So that means the tomcat.apache.org virtual host will have a greater range of ciphers available to clients than the www.apache.org. Now, you might have noticed up until this point, I've talked about TLS, 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 haven't really mentioned SSL at all. And one of the things that I'm sort of on the fence about is whether or not we should change a lot of these configuration attribute names. A lot of the names we've tried to carry over from earlier versions of Tomcat where SSL was used. The internal Java APIs still use SSL, so for that reason that's why we're still using SSL in this configuration. But certainly within the documentation, and we're talking about TLS, we perhaps need to change to use TLS everywhere for consistency. But then again, that might make it a little bit more difficult for people to upgrade. So there are pros and cons for making the SSL to TLS change. And personally, I haven't really made up my mind. If anybody's got any particularly strong feelings, then please do let those be known on the mailing list. So in order to support multiple TLS virtual hosts and multiple certificates, we've had to move some of the configuration attributes around. Nearly all of the TLS attributes have been moved from the connector. The only ones that remain are secure, scheme, and SSL enabled. Everything else has moved to the SSL host config element, with the exception of any attribute that is specific to an individual certificate, and that has moved to the certificate element. You've The full details of all of these changes are in the Tomcat 9 documentation. I should also say, if you start Tomcat 9 up with a TLS configuration from Tomcat 8, it will map all of the connector level attributes across to one connector with one host and one certificate, and it will do that for you automatically. That automatic mapping is likely to stay in place for the life of Tomcat 9. It is likely to disappear in Tomcat 10. So if you are doing an upgrade, you've got that there to help you get started, but at some point within the Tomcat 9 lifetime, you really do need to migrate across. So in terms of future plans, all of these TLS changes I've talked about for Tomcat 9, we do plan to backport to Tomcat 8. We also want to backport all of the other connector changes as well. There's been a lot of refactoring, a lot of cleanup. We've added HTTP2 support, which we'd like to add to Tomcat 8. We've also removed a few things as part of that cleanup, support for blocking I/O and support for Comet. And all of that is going to get backported to Tomcat 8, effectively in one big go. My best estimate of when that's going to happen is early 2016, so early next year, and it will be backported to a new 8.1.x branch. We will run 8.0.x and 8.1.x in parallel for a fairly short period of time. I would imagine no more than a couple of months. And once we're happy that 8.1.x is stable, then we will discontinue support for 8.0.x. And then the expectation is that users will move across to 8.1. As I say, I'd expect that to happen fairly quickly, i.e. within a couple of months. Other things that we're thinking about sort of within this sort of feature area, you might have noticed that we've got two places where we're configuring virtual hosts. There's the SSL part that's nested in the connector, and then there's the host element that's nested under the engine. And it probably makes sense to merge those. It would certainly make management a simpler, configuration simpler. However, they're not perfectly aligned. There are a couple of edge use cases where you might actually want to have them separate, and that's something that we need to think through and work out whether those use cases are valid use cases, and if they are, how exactly do you want to handle them. So I think merging the two is the right thing to do. Currently, we've got dynamic management of hosts with the host manager. We need to add in support for the TLS aspect of things into that. That's probably something that will happen after the merging of the TLS host config, sorry, SSL host config and host. If that doesn't happen, then we'll need to come up with some alternative plan for those host configs. So that wraps us up what I wanted to talk about in terms of TLS and virtual hosting. Now would be a good time, if you haven't already, to start typing those questions into the chat window. Let me have a quick look. Okay, first question. Since we're inserting ourselves between the socket and the SSL context, this is when we're doing the look ahead to read the SNI extension. Is there an opportunity to do the HTTPD style magic where we can detect a non-TLS request on a TLS-enabled socket and reply with a nice plain text HTTP response saying, you probably meant to use TLS here, or you haven't used the right port here, have you? Yes, there absolutely is the ability to do that. All of the hooks you need to do it are there. What would you need to do? You've got two choices. Either you try parsing it, I think what you probably want to do performance-wise is try parsing it as TLS, because we actually have to parse our way through all of the various bits of the TLS handshake until we get to the SNI extension. So start parsing it as TLS. If that fails, then try parsing it as plain text HTTP, and then if that fails, then we just throw an error and give up and say, nah, can't read this. Exactly, we need to think about how we pass that further on down the processing chain, and making sure that things like it's not marked as a secure request and the like, but that should be doable. Okay, do we have any more questions? I will just remind you, whilst you're thinking of any questions you might have, that this is being recorded, and I will hopefully be uploading a recording of this presentation to One, going twice. Okay, John, well, thank you all very much for attending. I hope you found that useful. If you do have any other feedback to provide, please do provide it via the mailing list. Thank you very much for attending, and goodbye.